Hi, today we are going to learn on how to draw the possible Lewis structure of molecules and ions. So, at the end of this lesson, students should be able to draw the Lewis structure of covalent species with single, double, and triple bonds and compare the bond length of these bonds. How to draw the Lewis structure? There are 5 steps to draw the Lewis structure. The first step is to count the total number of the valence electrons. The second step, we need to write the skeletal structure of the molecule. Next, we need to draw the single bond between the central atom and the terminal atoms. And then, place the remaining electrons as lone pairs to make the atoms octet or duplet. Finally, if the octet rule is not satisfied for the central atom, try adding the double or the triple bonds. Let's consider the first example, drawing the Lewis structure of NF3 molecule. The first step is count the total number of the valence electrons. In this molecule involve 1 nitrogen atom and 3 fluorine atom. Nitrogen atom has 5 valence electrons and fluorine with 7 valence electrons. So that gives the total number of the valence electron with 26 valence electrons. Next, write the skeleton structure of a molecule. In this step, we have to decide the central atom and the terminal atom. The more electropositive atom will be the central atom, and the more electronegative atom will be the terminal atom. Since N atom is less electronegative than fluorine atom, thus N atom will be the central atom, and the fluorine atom will be the terminal atom. The third step is to draw the single bond between the atoms. Since forming 3 single bonds between the nitrogen and the fluorine atom, we have used up to 6 valence electrons. Therefore, from 26 valence electron, subtract with 6 valence electron, we have remaining electron of 20 valence electrons. These 20 remaining electrons we will place as lone pairs to make the atoms octet. First, locate the electrons to the fluorine atom. So fluorine will receive 6 electrons to become octet with 8 electrons. And nitrogen will receive 2 valence electrons to make it octet. And finally, check whether the central atom satisfies the octet rule. If not, try to add double or triple bonds. Since the fluorine atom has 3 lone pairs and 1 bonding pairs, so that shows fluorine atom was surrounded by 8 electrons. This was satisfied the octet rule. While the nitrogen atom with 3 bonding pairs and 1 lone pair shows the nitrogen atom also have 8 electrons. So this is also satisfied the octet rule. Therefore, this molecule has achieved octet configuration and satisfied the octet rule. For the next example, let's consider the Lewis structure of HNO3 molecule. First, count the total number of the valence electrons. It gives 24 valence electrons. The next step is to write the skeletal structure of a molecule. The electropositive atom will be at the central position and the electronegative atom will be the terminal positions. Since the hydrogen atom is the most electropositive atom, but it only can have a duplet configuration, so hydrogen atom is impossible to be a central atom, to be bonded with all the atoms. Thus, nitrogen atom will be the central atom, while the hydrogen and the oxygen atom as the terminal atoms. Next step is to draw the single bond between the atoms. By forming 4 single bonds between the atoms, we have used up to 8 valence electrons. From the total of 24 valence electrons, minus 8 electrons from the bonding pairs, so we still have remaining 16 electrons. Next, place the remaining 16 valence electrons as lone pairs to make the atom octet. So we have used up all the valence electrons. So no more valence electron to be distributed. And finally, check if the central atom satisfies the octet rule. If not, try to add double or triple bond. Since all the oxygen atom has achieved octet configuration with 8 electrons, while the hydrogen with duplet with 2 electrons, but nitrogen atom was not satisfied the octet rule with only 6 valence electrons. Therefore, we can use one of the lone pair from the oxygen atom to form a double bond. So now nitrogen is satisfied the octet rule. The next example is drawing the Lewis structure for the CO3 2- ion. The first step is to count the total number of the valence electrons. Since this is a polyatomic ions, we have to include the charge on the ions. Add 1 electron for each negative charge and subtract 1 electron for each positive charge. So now, in CO3 2- ions, we have total 24 valence electrons. The second step is to write the skeleton structure of a molecule. We have to decide the central position and the terminal position of the atoms. Since the carbon atom is more electropositive than the oxygen atom, so the carbon atom will be the central atom and the oxygen as the terminal atoms. Next, draw the single bond between the atoms. All the bonding pairs to show the bonding between the carbon and the oxygen has used up to 6 valence electrons. Out of 24 valence electron, minus 6 valence electron for the bonding pairs, we still have 18 valence electron remaining. The remaining 18 valence electron should be placed as lone pairs to make the atoms octet. So now all the valence electron has been distributed. Final step is to check if the central atom has satisfied the octet rule. If not, try to add double or triple bonds. Since all the oxygen atom has 8 valence electrons, so they are satisfied the octet rule. But for the carbon atom, there are only 6 valence electrons. So one of the lone pair from the oxygen atom can be shared between the carbon and the oxygen to produce double bond. So now all the atoms in the molecules of ion has achieved octet configuration or satisfied the octet rule. The fourth example is drawing the Lewis structure of NH4+ ion. First, count the total number of the valence electrons. Since this is the polyatomic ions, we have to include the charge on the ions. The positive charge, we have to add 1 electrons. So in this molecule of ions, we have a total 8 valence electrons. The next step is to write the skeleton structure of a molecule. The electropositive atom must be at the central position and the more electronegative atom will be the terminal positions. So since hydrogen atom is the more electropositive atom, it should be as a central atom. But it is impossible for the hydrogen because hydrogen only can form duplet configurations. Therefore, the nitrogen atom will be the central atom. Next, draw a single bond between the atoms. From 8 valence electron, we have used up 8 valence electron to form a single bonds. Therefore, no more remaining electrons. Since there are no more remaining valence electrons, so there are no lone pairs on the atoms. Finally, check if the central atom has satisfied the octet rule. If not, try to add double or triple bond. Since in this molecule of ion, the hydrogen has formed duplet configuration, while the nitrogen form an octet configuration, so the molecule of the ion has satisfied the octet rule. Now, let's try these examples. You can check your answers by viewing the tutorial video. This is an assignment for you to complete. You can watch this video again if necessary as a guide for you to solve these questions. Thank you.